copying the objects to some memory that is stored somewhere without actually using the API, which is the API usually automatically increment that reference for you. And then the same thing. And finally, which is the case of the bug that we're going to analyze, is incorrectly use of the API. The API is good. You just need to use it as it's supposed to. And there are many functions that we're going to see in a bit on how you should manage objects. And if you don't do it the good way, you can get a use after free. So how you exploit a use after free? Then let's go back to 12-year-old grade again. We have two moments: get free and get use it. So basically what you do is, in the middle of those things, you get to allocate some memory in order we replace what it was being free. And then you use that thing and you get execution. That's how it works. Pretty simple. 3 moments. 1, the object gets free. 2, the object gets allocated by something that we control. Obviously, that's important. We have to control whatever we allocated. And then finally, we use it. And when we use it, we are obviously using it in a different way it was supposed to be used. For example, in the case of objects, objects has as the first word a B table. Basically, a B table is a list of all the functions inside an object. So basically, you replace the first D word with whatever you allocate, and then instead of using the original B table, we'll be using your own B table. So let's get a little bit of the details behind how Internet Explorer works with objects in JavaScript and Visual Basic Script. So we can go a little bit further. So basically, Microsoft created this very interesting model, which is called COM, Component Object Model. Basically, it was a way to centrally implement objects. So basically, it's just a standard that tells you, this thing should be here all the time in order to do the following thing, blah, 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 blah. And it's widely used, like every object in C++ is using cons pretty much. The thing about com is that they only have 2 requisites. Basically, the objects are responsible for their own creation. The idea was that let's make a way to create objects that we can use on C#, C++, Visual Basic, JavaScript, like generically. And the response to that was the com object. So basically, originally the com object has only 2 requirements. First one, it has to maintain their own reference counter. And the other one, they are responsible for creating themselves. And basically, what makes a com object is that it has to inherit from the E and O interfaces. The E and O interface export 3 methods. The first one is the query interface, which is the one that is in charge of returning an interface from an object. And then we have addRef and release. addRef, increment the counter. Release, decrement the counter. These are no API functions. These are methods that you should have on your objects in order to make it compatible with com. After creating com, they came out with a new way to automate objects in order to use it on programming languages such as JavaScript or Visual Basic Script, which are managed languages. So in order to do that, basically they create a new interface called iDispatch. And iDispatch is basically doing the resolution of functions based on names. So this was designed originally for Visual Basic, but then when they start using a lot more of interpreted language such as Visual Basic Script and JavaScript, they extended to what is called the iDispatch X, which is the one we are seeing here. And you have to export all these functions in order to be compatible with all the automation. And basically, what we care in this case is going to be the following functions: get this ID and invoke X. Get this ID basically transform a name. Let's say you want to access an object with a property which is like hello. So basically, you send to get this ID the word hello, and they will look into your internal database if that property is inside the object. If it is, it's going to return a number which is referred to that property. And then the function that you can see here, invoke, is the one that in charge of actually calling the method of the property with this ID, which was returned by get this ID. That's how it works. And then you have other things that we're might see later a little bit, like get next this ID and stuff like that, but it's more related to interpreted language. So this is how underneath works on a, in JavaScript and stuff like that. Even if you want to implement your own like usage of all the automation in your program, you call it that way. You basically, if you have an object, which is an iDispatch, you ask for the get this ID, which I've already said, send in the name of the property or the method. And then you call invoke x, which this ID that was obtained through the get this ID. You get that number, and with that number, you actually call the method of the property. So let's speak a little bit about variants, and we will soon get down to business, but we have to go through all the introduction to understand a little bit later. So variants basically are a common way to communicate with COM objects. They're very simple data structures. Basically, it has a small field that says which type of content that variant has inside, and then it has a big union with a lot of different types of things that variant can hold. And as you can see here, that you can have like a long, you can have like a byte, you can have a string, and you can have what is useful for us, which is you can have an iDispatch, which is basically an object. So if your variant is of type 9, it will have an iDispatch. The interesting part about the variants is that each functions that receive a variant, which usually properties and methods inside all the objects, basically they have to be in charge of parsing their own variants in order to check out the content. So for example, they receive a variant which is a generic variable. That's what variant means. And they have to check if it is an integer, then do the following. If it is a string, then you have to handle it that way. If it is an iDispatch object, you have to handle it the following way. And that usually introduces a lot of bugs, which is actually, I think that the problem that the people have on the bug that I'm going to explain later is basically because they didn't expect all the different types of objects. Anyway, these are the basic API functions. The first one is the variant init, which basically initializes a variant. They set it to null or to empty, actually, which is the most basic type of a variant. Then you have variant clear. Variant clear basically cleans the variant. In the case of, which is what we care about, in the case of an iDispatch object, if it receives an iDispatch object into the variant clear, what it's going to do is going to go release. And release, remember from one of the first slides, it basically decrements the counter. What I didn't say about release is that when the counter gets to 0 inside the release function, it's going to actually free that object. So that's important. So basically, if you decrement your counter to 0, you will get that object free. So that's so variant clear basically tries to clear the objects. If it sees that it's an iDispatch, an object, it's going to try to call release. So basically, it's going to decrement by 1 the counter. And then you have variant copy, which basically copy a variant from one to the other one. It does a couple of interesting things. For example, on the destination, it's going to call variant clear, meaning that if that's an iDispatch, it's going to call a release on that object. And what it's going to do is it's going to increment by 1 the source. So because basically we are copying into somewhere else, so we have to increase the counter. And finally, one of the other very used API functions of variants is the variant change type, which basically allows you to change from one variant type to another variant type. What you can see here is that this is the destination, you have the source, and this one in here is the type that you want the transformation to be. And exploit-wise, what is interesting for us is that it's going to do a variant clear on the destination. which means if it's an object, it's going to call dispatch. And if it's on the source, it's going to increment it by 1. It's going to go add red. So let's talk now about the bug. The bug apparently was exploited in the wild. Basically, the payload just download an executable from nodes.topics21century.com that obviously trigger global high security risk, and everyone got scared of the new day of the day. And the interesting part was that when we, that's what we do for a living, we start writing the exploit for this bug. We found out that the actual bug being exploited on the wild was very, very bad. And that was actually what makes the A of the APT being aleatory instead of being advanced. Because we figured out that it was exploited in a way that didn't make sense at all. And the interesting part was that once, I was actually doing an exploit. So when I found out like, these guys are exploiting this way, and then I started looking for other people exploiting use after free, I found out that everyone was doing the same. So that's why I'm here trying to explain use after free. So basically, a little bit about the bug. The bug was on what is called DHTML behaviors, which is something that was introduced in Internet Explorer 5.5, and it goes all the way to Internet Explorer 7. On Internet Explorer 8, it's not there anymore. I don't know if actually someone used behaviors or not. Behaviors are basically components that allow you to encapsulate specific functionalities on the different page behavior or elements. Among the many things that you can do on the behaviors, one of them is persistence. You can persist elements through behaviors. And one of them was the user data behavior, which basically allows you to persist the state of a page by using an XML store. Apparently nobody was using those things. But the bug was there. It was on the behaviors, and basically was on the set attribute function. Basically, the set attribute function, what it does was, it was transforming, I was actually saving an attribute based on a name that you can invent, and a value, which is the actually thing that you want to persist. And internally, what it was doing was, it was transforming into a string by calling variant change type. And while they were doing that, they basically used for the destination and the source the same variable. So if you guys remember what variant change type X do, is take the destination and call release on it. So basically, if you send as the attribute value dispatch an object, it was actually releasing, or at least calling release on the objects, and then decreasing the counter 1 time. So this is basically a debug session of the bug. Basically, you can see the first two are the first two arguments, the destination and the source. And as you can see, are both the same. So that means that that object or that thing that was introduced was called release 1 time. So then you came back to aleatory persistent thread. Now I'm going to ask a question, like whoever wants to respond it will be okay. How will you exploit this kind of bug? You have a set attribute function that allows you to